Hi, I'm starting a new project, and for context, I thought it might be fun to go over a previous iteration of the project. I'm Jonah at TG-Techie, basically everywhere, and we'll be talking about this. It's what I call the TG Watch, but it's a touchscreen smartwatch I made back in around end of 2019, early 2020. And what you're watching right now is an unstructured chat about it in preparation for the next version, which I've started some work on, but never actually did some actual chatting about this. So, first off, when I say touchscreen smartwatch, what I'm referring to is a microcontroller inside of a chassis, all from scratch, including the motherboard, circuit board, and it runs Python. This is what I wear daily now, but it's wearing thin, and the other models of it I built have become out of commission over the years. So, to hop in, why did I make this? I recently graduated college, but I started this when I entered and I was looking for a challenge. The maker market environment community was ready at the time to make a smartwatch at home, and it was a great learning experience. If that does not come through here, then I have not structured the unstructured chat enough. So to hop in, let's take a look at the anatomy of this. I have another unit of it here opened up, and I thought we'd go over what's in it. There's this primary circuit board designed in plug your nose and ears, EagleCAD, now of course KiCad, which contains a NRF 52840 microcontroller, a temperature compensated real-time clock, a bodged on battery gauge. Oh, I'm sorry, is that not close enough? Here we go. Okay, we have an NRF 52840 microcontroller here, some flash for circuit Python, a haptic motor, a precision real-time clock, a battery gauge that's been bodged on here, and then here we see one of two cables connecting to a touchscreen on the other side. And we'll come back to that in a moment. But what these watches run is CircuitPython. Small modifications, and it's built for this specific board. But I believe it's still up on the website. If you go take a look at circuitpython.org, and you can see the PWM there. Oy. Anyways, so touchscreen smartwatch. Back to the anatomy. Here we have the cable that connects to the touchscreen, an interrupt over I2C. There's an accelerometer, and what seems to be odd for some, a USB-C port on a smartwatch. Now, because this runs CircuitPython, it was a lot easier to include a USB port when uploading code, etc. But that covers the basic anatomy here, other than the battery. So again, this is unstructured. Pardon as I improvise as we go along. So this is what the final product looks like. But there was some journey to get there, especially as a maker learning how to do this at the time. So I have here a selection of things from the process of making it, from early chassis designs, which in comparison, quite bricky and chunky. If you can't see, the final version has a curved, almost drop-like shape. This is just a box. And it slowly progressed as my CAD skills improved and an understanding of what the problem space looked like at the time. But what the case finally ended up being with, these are all 3D printed, sanded, some of them, but 3D printed on a Ultimaker at the time. That's what the M5 Makerspace had. And the final chassis version, which we see here and here, is made out of SLS printed alumide, which is nylon, powdered nylon, and powdered aluminum mixed together and sintered. Although this specific one I'm holding, I think, is just dyed nylon. Okay, this is not part of what was ever actually inside one of the watches, but I thought this was fun, and I forgot that I did this. When initially waiting for the first revisions of the circuit board to come in, I 3D printed a version of it while trying to figure out what the casing would look like in specifics once the actual boards had come in. And it's a lot of fun. Not something I've repeated since, but a technique that is certainly fun to have in one's back pocket. Okay. So this is a casual overview so far, but we'll go into some depth later. Here we have the next item, which is the first version of the fully assembled watch. This is like revision 0, depending on your preference for numbering. And it is a little more sparse and has some different bodge wires from what you saw. Notably, it had here a just directly soldered battery, something that's a mistake I did once and have not repeated again for projects. And yes, one thing that the final ones did not have, but this first revision, so revision 0 did, was here in the bottom left. There's a little mezzanine connector, also known as board-to-board connectors. Zach's jerry rig calls them little Lego connectors, and that was my unexperienced attempt at creating a standard interface between this board and whatever needed to be plugged into it. At the time, when I was first working on what it needed to be, what it would have, the plan was to add 2 little capacitive buttons along the side with a little flex PCB. And it turned out, which I now know, and I imagine a lot of the watchers do, capacitive touch is not as simple as it looks. It is deceptively difficult to get tuned or to match what you need precisely. And I certainly didn't have the expertise to do so at the time. One thing that significantly changed between this revision 0 and the revision 1/revision 2 that I wear now is the placement of the USB Type-C port. I have here an empty shell of the revision 2 chassis, and we can see the USB port is nudged ever so slightly to the side, and that was done for routing reasons. I'm one who's a-okay with, when you're routing a circuit board, going back and, if possible, depending on pin function, changing the precise allocations of pins on a microcontroller to the things they're connected to, etc., if they work, provided, of course, and not rigidly requiring that the board always be directly as the schematic was created. I think there's often a flow back and forth that one can reach when trying to better solve a problem, like when you're shrinking the problem space. Where were we? Yes, the USB port was nudged over. That was not between schematic and PCB, but between PCB and chassis, where after some experience, it made more sense to have a version 1 motherboard. Yes, it made more sense for the added chips and routing from the revision 0 to the revision 2 boards to move the port. Let's see, do I have, I'm gonna grab something to hold that up a little closer. Here we go. So why am I rambling on about this? Great question. I enjoy tech. I hope you do too if you're this far into the video. So we're still in the overview, even though we touch on details. And let's see, next on the list. Yes, the battery. So the battery, as mentioned in revision 0, was soldered right to the motherboard. If to others out there who've made that mistake, you have my sympathy and you're not alone. The second version, there's version 1 and version 2, used a different means of connection. It had I modified the batteries that were being used, the lipos. Oh, come on, focus. There we go. I added an itty bitty mezzanine connector to them. And this turned out in the long run to be better because it was modular and small, but an absolute pain. Fabricating the little circuit boards that were used for those mezzanine connectors was and is a nightmare, and have been one of the things that absolutely need to change for the next version. Let's see, focus. Oh, there we go. Battery and USB. Yeah, I think that's the short overview of all of the components. Other than the watch band. So the watch band is a standard watch band. Because why not use the standard when available? Although, maybe I should have done that for the battery connector as well. Okay. It's a ramble, but let's jump into some detail about some of the specifics. So let's start with chip selection. Okay, so the brains of this watch are here. This is a Braytac PCB module with an NR52840 on it and antenna. Although it does not contain all the required crystals for the watch to function, which is a good lesson to learn the hard way. One thing that I hope, if you take anything out of this video, is to read the datasheet always and cross-reference datasheets, especially when you're using a module produced by a company that uses a different chip. So why choose the NRF52840? So at the time, Python was my favorite language. It still is one of my top 2 favorite languages. And I absolutely knew I wanted this watch to run CircuitPython. For those who aren't familiar, CircuitPython is a branch of MicroPython. Very helpful definition. But it's a version of a Python interpreter written to run on microcontrollers. And the CircuitPython branch of that interpreter is maintained by Adafruit. And they have geared a lot of the changes they've added towards standardizing library, adding support for chips that they use in their boards, etc. The NR52840 came out just around when I decided I wanted to make this project and challenge myself. So picking that was a good extension, and it came with, or there existed a module which handled all the Bluetooth fiddly tricks for the antenna. It also has native USB support and a USB-Fi integrated, which means when you plug the watch in, like all modern supported CircuitPython devices, it shows up as a USB drive, unlike an NR52832. So, NR52 chosen because it was a good choice that supported Bluetooth at the time for CircuitPython. I think this is 8 megabytes, 16 megabytes of NOR flash, and that's used as the place that CircuitPython stores the programs and files you upload. Continuing on with tidbits about chip selection. Let's see. Let's talk about this bodged on battery gauge chip. Now, I could not for the life of me remember the precise name of that chip. off the top of my head right now, in part because it has been problematic. Oh no, the original chip that was on there, right? The original chip that was on there was problematic, and the bodged one, I think, is a Max 17048. The one that was on there before started with an LC, and the difference there is that the first chip that was picked for battery gauge, I don't have a version without the bodge. The first chip, right below the first chip was picked for the battery gauge, did not work nicely with the NRF52840. I cannot recall the specifics. I don't think I ever dug into them at the time, but it would quite often fail to interface over I2C. And using the battery voltage divided through two resistors is not a great way of measuring battery capacity or effective state of charge for devices that draw any appreciable amount of current in a given short period of time. If you're incredibly low power, I imagine there's many applications where that's more than fine. But for better or worse, this is not a low power, relatively speaking, device. It uses a linear regulator, something that absolutely would be changed. Yes, so bodging this on the original chip that was on there I need a zoom in microscope if we're doing this again. There's two little solder balls or blobs of solder to the left of the bodged on module, and I have that module here. And it's just a little itty bitty baby board with three pads, a footprint for the Max IC, and then one resistor to quote unquote lie to disable the feature of the chip that double checks the temperature of the battery, because these batteries do not have a temperature output. Okay. Okay, still there. That was a lot of fun to engineer. How do you add this little chip back on? And the two solder blobs that are distinct from those three pads solder onto what previously was a shunt resistor that measured the current going in and out of the battery. So this is not a Coulomb counting device. This is instead some quote-unquote dark magic inside of the chip. And they're running an algorithm in there. I would refer to the data sheet if one is so interested. Okay, chip selection. This accelerometer is from a company that's recently becoming one of my favorites, but at the time it was just the one I picked because it was available, had software support in CircuitPython, and had the features needed. So this is an LSM6DSOX, and it has some integrated functions in it for running algorithms like step detection and tap and gesture detection. Of course, these are things that could be integrated and programmed on the watch, and I definitely got around to. Anyways, all of the chips that I selected to run or to use in any of the versions of the watch at the time were chips that already had software support in CircuitPython. That was chosen for pragmatic reasons. I wanted to get this project done as fast as possible at the time, and writing drivers from scratch was something someone with some making experience, but not a whole lot, would have taken a lot of time to do and learn the process of. So I picked chips that already had software support. And of course, debugging a library for a chip is a lot easier than writing one from scratch, with, of course, asterisks. So, next, the board and the screen. I thought it might be illustrative to see how this, oh, you can't see what I'm gesturing to. See how this, the motherboard, is connected to the screen. Now, this is a capacitive touchscreen acquired from, I think, Shine World on Alibaba. But they're a screen manufacturer, delightful, and they have a wide catalog. But this screen has two, focus. Here we go. These screens have two connections. A FPC, FFC? I always forget. A flat flex ribbon cable that plugs in on the back side of the watch. And then a second distinct cable that is a board-to-board connector and some FR4 for the touchscreen. Let's see. Can we disassemble this easily? Yes. Okay. Here we go. Two cables. Now, again, this is one of the things you do once and never do again. I picked to use the same connector for the battery, the same board-to-board connector for the battery connector as was already used for the touchscreen connector. This is something I'll never do again, just because it allows for the possibility of accidentally plugging things in the wrong place. Something I have done once on one of these at least. Yeah. Yes. How is this assembled? So one of the things that absolutely needs to be changed in future versions of this project is how you access and repair this. So the watch right now, this version 1 and the revision 2 and revision 0, the screens are RTV siliconed right into the chassis, and getting them connected to the board while bonded to the chassis is a right pain. As you can see, it won't be possible to show you on the camera. And then even when they are connected, it is difficult to angle the board safely such that you can slip the USB connector into the hole. But one advantage of this selected setup is that it was relatively thin. Definitely something that could use some refinement, but A-okay is the first pass in my take at the time. So we've done a little bit about chip selection and the screen, etc. The battery and the connector. What else is fun in a short, unstructured? Okay. So the buttons. I did not grab the example I needed for this, but this version of the watch, when you're developing software, I'm sure as you have done, you often need to rerun or restart things. And it has, all the revisions had a small hole behind the wristband that you could stick a little pin in to reset the microcontroller. Now, this is fine enough when you're sitting down, plugged into a laptop. But buggy software is buggy software, and it is often, especially with the early versions, you need to reset it twice a day as things happen. And as luck had it, the switch I initially picked for this, this is a Rev 1 board. This switch is not particularly durable, especially with the angle that the paperclip ended up interfacing with the chassis, and they would often break. And I have an example of that here. And this one also has another problem, but maybe we'll get to that some other time. So the switch in the top center for resetting the microcontroller is borked. It's been poked off, and later revisions of the board switched to a different right angle surface mount switch. Part number would of course elude me. I think it's a KMR2. No, it's like the right angle version of the like classic tiny white tactile switches. If one is really interested, I can find it out later. Okay. What went well with this watch was it's a functioning watch, and what went well was that I learned a lot from this process. It's still, this model, this instance is still up and running 5-ish years later, and has taught a lot. I made this as a maker, and I'm now taking a second pass as an engineer. And what the next version of the project will require, I think, should go in a different video. I know this was a scrambled overview of different thoughts and bobs and many tangents, but I hope you enjoyed it as much as I did. There's a couple other fun stories in here, like debugging improper reset circuitry, etc. But that should be for a different time. Have a nice one, and if you made it all the way to the end of the video here, thank you for watching and listening.